So here we have our note on electrical resistance and what we call Ohm's law. And so we've talked a little bit as we've progressed throughout this unit. We've talked a little bit about resistance, but let's go into a little bit more detail here. Resistance is what we call the ability to slow down or resist the flow of electrons. In conductors. Okay, so that's resistance. It's the ability to slow down the flow of electrons. Electricity is converted into other forms of energy when it meets resistance. So for example, sometimes when electrons meet resistance, it's turned into heat energy, and this is what happens when you connect an electric circuit and the wires get a little bit warm. It's because the wires have resistance. Certainly, sometimes we see light energy being produced, and that's the case of an incandescent light bulb. But these are examples of the forms of energy that might be produced when this energy, this electric energy, meets resistance. So the symbol for electric resistance is R, and the SI unit is the ohm, okay? And the ohm has a unique symbol. It's the Greek letter omega, and it kind of looks like an O with two little feet, so you can draw it like this. And that's the symbol for resistance. All right, an electrical device that we might see in circuits, and we've talked about this, is called a resistor. Okay. And all loads, every single load that we're going to use has some type of resistance, so they resist the flow of electrons. A resistor doesn't, it's a type of load that really doesn't serve any purpose other than to restrict the flow of electrons. So let's do a little bit of a recap. The name of a substance that allows electrons to easily flow through it is what we call a conductor. A substance that does not allow electrons to flow through it is an insulator. And a substance that allows some electrons to flow through it, we would call that a semiconductor. So some examples of conductors, we know this well. Silver, copper, gold, and aluminum would be kind of four classic examples of really good conductors. Insulators, we know this almost as well when we talked about static electricity. Rubber, plastic, like polyvinyl, etc. So these are some examples of insulators. And semiconductors, things that allow some electrons to flow through them. In particular, silicon, which is what microchips are made out of, glass, sand. These are, of course, all things that are made from silica. And in general, there's a whole class of semiconducting materials, and we went over that in the static electricity unit. So these are just some examples of. So we come to, this is what resistance is, and now we're going to talk about Ohm's law for a moment. And Ohm's law states that the voltage between 2 points in an electric circuit is directly related to the electric current. And this is a big deal. So what this says is that if I have a circuit, the voltage that's flowing through any 2 points in that circuit is directly related to the electric current. So this term right here, directly related, you have to think to your grade 9 math. And what's going to happen, I've got a little demonstration to show you here. So what's going to happen is here I've got V equals IR. So this is V is voltage, I is current. And what you'll notice is here's the resistance, and you can see down here a little circuit. So right now I've got 3 batteries, 1.5 volts, and I've got a certain amount of current, 9.0 milliamps, and they're flowing through this big red resistor. And if I increase the voltage, then I'm going to increase my current. I'm now at 15.4 milliamps, and I can continue to increase the voltage, and I will continue to increase the milliamps. And so now this is important to note. So it's not just that they're related. Here's 1.5, and I get 3 milliamps. So now when I go to, I've doubled the amount of voltage, and I've doubled the amount of current. And now I've tripled the amount of voltage, and I've tripled the amount of current. So you can see what happens. Every 1.5 volts I add, I am, of course, now increasing a current by a proportionate amount. So this right here, thanks very much. You can see the web link for this, fet.colorado.edu. This is the University of Colorado. And these are simulations, physics and math and chemistry simulations. You should definitely check out this website if you're interested in playing around with some of these sims. Back to our lesson, we've got basically this thing right here. The voltage between 2 points is directly related to the current, which means that if we have something like this, and I've got voltage down here, and I've got, I've got voltage up here, and I've got current down here, and I change one with respect to the other, I get a straight line. And that's what this means. Directly related means a straight line. And the slope of this straight line, we're going to use orange. The slope is equal to the resistance. So this is what Ohm's law tells us. And here is our formula. Resistance is equal to voltage over current. So it's the same as what we did. It's the same as what we're talking about up here. When we rearrange this, the units for electric potential are, of course, volts. The units for current are amps, and the unit for resistance are ohms. We're going to draw this symbol again just so that you can get used to drawing it. Amps is, of course, an A, and volts is, of course, a V. So here are our units, and what we end up with is this relationship between resistance, current, and voltage. Now, just as we did with density, I'm also going to show you the triangle, okay? So if you want to know what, say, voltage is equal to, you'll see V then is equal to IR. And if you want to know what resistance is equal to, then you will see V over I. So resistance is equal to V over I, right? And then similarly, if you want to know what current is equal to, that's V over R. So this is just a nice little way, a handy dandy little way of remembering our voltage, resistance, and current relationships. And so now we've got a couple of problems that we're going to solve using our typical method. And so let's just jump right into example number 1. What is the voltage drop across the tungsten filament in a 100-watt light bulb? Okay, so that we're trying to figure out what we're being asked is for the voltage that's being used, which we don't know, that's our unknown. The resistance is 144 ohms. So resistance is equal to 144 ohms. Ohms is indeed what we have, and we now have a current of 0.833 amps. Because we want to know voltage, again, we can come up here and we're going to say, okay, well, if we want to know what voltage is, V is equal to I times R. That's our formula that we're going to use. And so now we can substitute 0.833 amps times 144 ohms. And we'll do a quick calculation using your calculators. Yes, you can use your calculator at this point. And so when we do this, we get 0.833 times 144. We get 119.952 volts. And we're going to round this to 120 volts. And we always end with a statement because this is a word problem. Therefore, the voltage drop is 120 volts. Okay, so there's that. Example number 2 is very, very similar. An invisible pig zapper. I don't know what a pig zapper is, but it's what this question is about. An invisible pig zapper has a voltage of 25,700 volts and sends a current of 45 amps through the cute little pig if it tries to escape. So what is the resistance of Babe? So this is like an electric fence on a farm, and I'm not too sure, I can't tell you because I've never lived on a farm, whether or not these numbers are accurate. However, I would imagine that 45 amps, that seems a little bit high. So let's calculate the resistance of Babe the pig here. We know that voltage in this case is 25,700. Holy smokes, that's a very high voltage, and an even higher current, 45 amps. There's no way 45 amps. That's definitely enough to kill poor Babe the pig. And the resistance is what we're trying to find out. So again, now we want to know resistance. Let's take a look at our triangle. If we want to know resistance, we got V over I, okay, is the formula that we're going to use. So resistance is equal to V over I. And so here we have 25,700, and we divide by 45. And so when we put this into our calculator, which I'm going to do right now, 25,700 divided by 45, I get 571.1 ohms. And we would say, therefore, Babe's resistance is 571.1 ohms. So keep in mind, look at the format of how I'm solving these, right? So this is, again, using the GRASS method that we've talked about, where we list our given information, our required information, we talk about the approach, we solve it, and then we give a little statement. Okay, so the last question I'm going to leave as a try this question, and we can take this up in class. Okay, Mr. Jackson Stereo draws 110 volts and has a resistance of 17.5 ohms. Calculate the current. Okay, so this is try this, and if we if you get through and you want to check your answer at the end of the question, make sure I'll write the answer over here. I is equal to 6.3 amps. Okay, so there's the answer. So I want you to try this on your own and then check your answer right here. Okay, you'll notice the next page is a worksheet. This worksheet is for tomorrow in class for you to be working on. Okay, so one thing I'm going to say just before I finish this off is that sometimes when you're solving problems, the questions aren't always going to be perfect units. Sometimes you're going to have to do some unit conversions. Okay, so just keep that in mind, that unit conversions are something that's very, very common that you see from time to time in these types of problems. Okay, anyhow, there you go, your lesson on Ohm's law.